Right, with page 4, number 8 gets into our definite integral properties. We're told that we have an integral from a to b of f, which is equal to 5, and on the same interval from a to b, the integral of g is negative 1. Which of the following must be true? So let's look at the 3 right away. Roman numeral 1 says f is greater than g for the entire interval from a to b. Right? Not quite sure about that, so we'll come back to it. Number 2, the integral from a to b of f plus g is equal to 4. Okay, this one, that's one of our properties, right? We know that if we have two integrals, we can add them together. That's okay to do. Those are sum difference property. And 5 plus negative 1 is 4. So this is definitely true. What does number 3 say? Number 3 says the integral from a to b of f times g is negative 5. All right, and remember, the sum difference property is called that because it only works for addition or subtraction. It does not work for multiplication or division. So this is not, I'm going to say it's false. It is possible that it can work out, but it's very rare. It usually does not. Okay, and we're told which one must be true. So this is not necessarily going to be true, but Roman numeral 2 is. All right, so 2 has to be part of the answer, and 3 cannot be part of the answer. So we can see that actually everything but 2, everything but A rather includes Roman numeral 3. So our answer has to be A. Let's talk real quick about Roman numeral 1. What's going on here? This one says what must be true. So we're told that the integral from a to b of f is equal to 5, and the integral from a to b of g is equal to negative 1. So it seems like f is a larger function. In other words, what it seems like is that we have a situation like this, where here's a and here's b, and f is up there, and g is down here. All right, so that's why f's area is positive, right, because we're above the x-axis, and g's area is negative because we're below the x-axis. All right, but does that mean necessarily that f will always be bigger than g? Could we have a situation like this? And I'm going to need another, let me get my pencil out here as well. What if we had this situation? All right, here's a, and here's b. Right, and let me bring in f, and watch what f does. F is going to be high, and then it's going to drop down really low, and then go back up. All right, classic type of function there. All right, now what about g? G could be down here, and what if g were just to rise just a little bit, and then drop back down? If you look at all the area that is under the curve compared to the amount that's above the curve, it's still possible that g's ultimate value could be negative 1. F would have much more area under the curve, so it would be 5, but just for that instant, g was actually larger than f. So this one, again, could be false. And this one usually is false, but only one must be true, and that's Roman numeral 2. Number 9, what are all values of k for which the integral from negative 3 to k of x squared dx is equal to 0? Okay, so we know there's definitely one answer that's going to work, and that is negative 3, because one of our properties was that if we have the integral from a to b and a is equal to b, so in other words negative 3 to negative 3, the area will have not accumulated anything and will automatically be 0. So negative 3 has to be part of the answer. All right, so b is out. Now, the question is, what about 3? What about 0? Could it be 0 and 3 as well as negative 3? Here's what I would do. We know what this graph looks like. It's the graph of x squared. Let's graph it. Right? Here we go. Here's x squared. Right? We know that the integral represents the area under the curve. So we're going to start over here at negative 3. And we're interested at 0, and we're also interested way over here at 3. Well, if we go from negative 3 to 0, we have some area there. That's going to be a positive number. And we're going to have twice as much area if we go all the way to 3. So the only spot where there will be no area under the curve is if we begin and end right there at negative 3. So C and D are out, and once again, A is the answer. For number 10, our properties, we're told the interval from negative 5 to 2 of f is set negative 17, and the integral from 5 to 2 of f is negative 4. What's the integral from negative 5 to 5 of f? Okay, so there's a lot going on here. All right, so we know, for starters, let me put down here, the integral from negative 5 to 5 of f is going to be equal to the integral from negative 5 to 2 of f plus the integral from 2 to 5 of f dx. Okay, I left out the x's, but you get the idea. All right, the whole is equal to the sum of the two parts. Notice that when we stop at 2 for this integral, we pick up at 2 for this integral. So we have some numbers here. We know that negative 5 to 5, that's what we're trying to find. So this is our n, if you will. We're trying to figure out what that's equal to. The integral from negative 5 to 2, that's also given to us. That's negative 17. All right. How about the integral from 2 to 5? That's not given to us. We were given the integral from 5 to 2. So your spidey sense should kick in here, and you should think, okay, wait a minute. These need to be swapped. We want our smaller bound to be down below and our larger number to be up above. We can swap them. Remember what the property is, though. We must negate the integral. So this is going to be the opposite, all right, equal to the opposite of the integral from 2 to 5. All right, so if the integral from 5 to 2 is negative 4, then the opposite of that would be 4. So we're going to add 4, and negative 17 plus 4 is negative 13. All right, and then with number 11, we're asked to find the integral from 1 to 4 of 3 times f of x plus 2. All right, so this gets a little trickier here. We see that the integral, well, it's another one of the whole of the parts. We have the integral from 0 to 4. That'll be equal to the integral from 0 to 1 plus the integral from 1 to 3. I'm doing a lot of shorthand right here. 0 to 4 is negative 3. 0 to 1 is 2. And we're interested in 1 to 3 because, I'm sorry, this should be 1 to 4. My bad. I apologize. 1 to 4. Because that's what we're looking for right here. All right. So what number plus 2 is negative 3? Well, that would be negative 5. All right. So what we're just learning here is the integral from 1 to 4 of f of x dx is equal to negative 5. So this integral right here, if we break it down, is 3 times the integral from 1 to 4 of f of x dx plus the integral from 1 to 4 of 2 dx. So what do we have? We have 3 times the integral from 1 to 4 of f, which we just calculated to be negative 5. All right, so that's going to be negative 15. And then the trick is that we see the plus 2, so we want to add 2, and they want you to pick the negative 13, but you know better because we went over this in class. We know that this is the area between a is 1, b is 4, and the function is 2. All right, so it's a rectangle. We're going to find that area, and the quick way to do so is the function, which is 2, times the difference of the bounds, 4 minus 1. All right, 4 minus 1 is 3, times 2 is 6, so we have plus 6, which is negative 9. So the correct answer is negative 9, but the answer they're really hoping that you'll select is negative 13.